Okay, here's the first of three interesting related rates problems I'm going to show you in three separate videos. So this one gives us a rectangle, and it's labeled for us, x, y, and z. Z is the hypotenuse. And it's telling you all this information about its sides and how its sides are changing. Remember, these are rates. So dz dt is a rate, dx dt is a rate, and dy dt is a rate. The rate at which each of these sides is changing. So it says the instant when x equals 4 and y equals 3, what is dx dt? So we're going to have to come up with an equation that relates x, y, and z. And since this is a rectangle, that's pretty easy because we know that a rectangle has right angles, and thus that little triangle you're looking at is a right triangle. So we do know that x squared plus y squared does equal z squared. Now, the variables in this are x, y, and z. They're all changing. But when x equals 4 and y equals 3, at that moment, z is going to equal 5. We're going to keep that in case we need it. It's a 3, 4, 5 triangle. You can just do Pythagorean theorem. So we need to make a related rates equation, obviously, because all this information is rates. So take the derivative, 2x with respect to t. So 2x to the first times dx dt plus 2y to the first times dy dt. So they all differentiate very similarly. 2z dz dt. That 2 looks like a z. That's unfortunate. So we can just plug everything in right now. I'm not going to. I'm going to divide by 2. Just get that out of there. So we know you can do that because 2 isn't equal to 0, so you can divide whatever you want as long as it's not 0. So I just did that. Now I'm going to plug everything in. dz dt equals 1. dx dt is 3 dy dt. But look, I'm trying to solve for dy dt. So I don't want to get rid of this dy dt. I want it in there. So instead I'm going to say dy dt is 1/3 dx dt. I mean, if you think about that, that's going to make a lot of sense because we need to solve for dx dt. We don't want to get rid of them. So dy dt is 1/3 dx dt. And dx dt is dx dt. That's what we're solving for. So the only thing I haven't put in yet is x, y, and z. X, y, and z are 3, 4, and 5. Or 4, 3, and 5. So we have 4 for x, 3 for y. That's nice because 3 times 1/3 is going to be 1. And 5 for z. So that will be enough to allow us to solve for dx dt. So we have 4 dx dt plus 1 dx dt equals 5, which means we have 5 dx dt, just add them together, equals 5. Therefore, dx dt does equal 1.